Welcome to the next section of this class, Tips and Techniques Working with KNIME. In this section, we're going to talk about the data file handling. And this information is available. KNIME has published a very good article detailing this on their website. But I know there are many people who simply prefer to view this type of thing as a video where they can see things done in person instead of reading for 30 minutes. So I've gone ahead and produced a video to cover this same information. The first thing we need to cover is this concept of a path. And the path is a string that identifies where within the computer a particular file is located. And it depends, of course, on the operating system. So Windows and Unix would have different file system path formats. But there are going to be two types. There's going to be an absolute, where it's going to be, the path will represent the exact location of a file starting at the root file system. And then another one called relative. And a relative path does not identify a particular file or folder. It's used to identify a file relative to something else within either the workflow or the system. And we're going to cover both of these. There are two types of file systems that KNIME is going to support in all of the various file reader and writer nodes. The first and most common one, at least for me, has always been the standard file system. And we're also going to talk about later on in this video connected file systems. Standard file systems are available at any time, meaning you don't need a connector node to reach them. They exist somewhere on your computer. A connected file system instead is going to be one that might be, for example, on an Amazon S3 bucket or somewhere on your Google Drive. And we'll show examples of all of those. But to begin with, we're going to look at standard file systems. Their working directory is pre-configured and does not need to be explicitly specified. And you use a file reader and you just drag it onto your workflow, and then you can right-click and configure it directly out of that file reader. Now, with standard file systems, there's going to be different options that we can choose from. A local file system, a mount point, and a relative to, and there'll be three versions of relative to: the current workflow, the current mount point, and the current workflow data area. And then finally, a custom or a KNIME URL. And I'm now going to walk you through an actual hands-on video, and we're going to walk through an example of each one of these. With a local file system, when you're reading from a local file system, the path syntax used is going to be dependent on the operating system. We've mentioned that before. But the working directory will be implicit, and it will correspond to the system root directory. So let's take a look at just doing that with a local file system, just reading a file. So let's go ahead now and do just a simple CSV reader. So I'm going to do a search for CSV, and I'm going to drag the CSV reader up to a workflow, and I'll go ahead and configure that. And under my read from, this is where I specify the local, mount point, relative. So start with a local file system because it's just a file located on my computer. So I'm going to browse for that file, and this one happens to be on the C drive, and I put it in my temp directory, and it's called reference country master. So it's a hard-coded file. It exists. The directory is already there. Everything is relative. And so I can execute this node. And when I look at it now, I'm able to read this entire file. Of course, the problem is with this file is I can't pass it along to anybody else because it's on my C drive. So this workflow is only going to work on my computer. Or if I move it to another computer, it's not going to work. So I'm going to want to come up with a different solution to handle that. So let's look at a few ways by using additional options to handle this situation. Now, another version of the standard file system is called the mount point. Now, a mount point is an option you're going to have access to for anything such as a local mount point, which would be something like in Windows if you've mounted an external drive, or maybe in an AWS environment you've mounted an external drive. And it would look very much, of course, like it would have a drive letter, so it won't be any different to you visually. But you can also use a KNIME server, or you can access something from the KNIME hub. And again, so the folder paths are going to look similar to what they would if they were Windows or Unix. So let's just quickly show you how to do that as well. Okay, so I'm going to do the same thing that I've done before, which is I'm going to locate the CSV reader. But before I do that, I'm going to quick pop over here, and I'm going to connect up into here. I'm going to take the copy of this file, and in my KNIME workspace, I've got a directory I've created here called data. So I'm going to copy this file, and I'm going to copy it over here into the data directory. And now I'll come back in, and this time I'm going to drag my CSV reader node again out. And this time when I configure it, I'm going to tell it that I want to use a mount point. And the mount point by default is set to local. And what it's referring to here is this is my local workspace you see over here on the left-hand side of the screen. That's local. So when I browse for the file, it's going to be somewhere under that structure. So if I browse here, you can see if I move this over how the directory structure here aligns with all the directories that are here, Scott's examples, KNIME challenges, and so on. So I'm going to go ahead and go into the data directory here and take that reference country master again, and everything is just fine. I'm going to be able to read this. Just for reference, of course, apart from local, I could also make the mount point the KNIME hub or the KNIME example servers. And if you have the KNIME server, you can access the KNIME server directly from here as well. So let's go ahead and click OK, and we'll execute it and look at my file, and everything is just as I expected. So very similar in the difference between these. Now the next file option we have is the relative to option, and this is the one that's going to be most helpful when you want to distribute files with your workflow. In the relative to, we have access to 3 different file systems: the current mount point, and the current workflow, and the current workflow data area. The current mount point and the current workflow, the file system corresponds to the mount point where the executing workflow is being located. Recall in our last example we used the local space, and that was the current mount point. Now the current workflow data area, this is a file system dedicated to, and it's going to be accessible to not only just the current working workflow, but data that's physically inside of that workflow is going to be copied and moved or deleted together with the workflow. So if you export the data, export the workflow, and were to push that to another computer, for example, that data would be copied as part of your workflow. So let's take a look, and we'll try all 3 of those different versions. All right, so let's go ahead and create 3 different versions of the file reader. So in the first one, I'm starting with CSV reader again, and I'm going to open up the configuration again. And this time, under the read from, we're going to do relative to. And the first relative to we're going to do is the current mount point. Recall from our last example, the current mount point is the local workspace. So if I were to browse for the file I want right here, I can see that it has all of the directories match here. The purpose or the use case for doing it relative to the current mount point is it might be called something different on another server. As you move, particularly as workflows move from dev to test to QA and prod, oftentimes those workflow spaces will change, or their mount points will change. And you want to say it's in the mount point, but not necessarily identifying the mount point. So that's certainly one option. A second way you can do this relative to the current mount point, by the way, is then the current workflow. Now that's going to be right here under, if I browse, drag the window, you can see I'm in the current working directory is data handling. See, that's the workflow directory underneath, or the workflow group, excuse me, underneath my workflow, which is the data reader for standard file systems. So I can place the file there, which I have done in the data directory. I do something like this when I have a group of workflows that all share a common file. Maybe one creates a file and another one reads the file and so on. I use it as a good use case for that. Now the third one, I'm going to pop over to look at under my data file reader, the workflow I'm actually working on. I'm going to go ahead and I'm going to create a new folder underneath here, which I will call data. Doesn't matter if you case sensitive, it's case insensitive, excuse me. I prefer to capitalize the first letter of each one of them. So I'm going to come back here now and say relative to the current workflow data area. And when I browse, well, there's nothing in that data directory right now. So I'll come back here and I'll go back and I'll move this country reference under the data directory of my workflow. And now when I browse for that file, I can reference it from here. So all three of the relative twos are going to work the same way. I'll go ahead and click OK here and execute and browse my file. Again, the biggest advantage of the relative to is this workflow now. If you turn around and do an export of this workflow, the data area underneath here is going to be exported as part of your workflow. So that means if you've got a control file, it will move with your workflow. That's really important. You'll see that used all throughout the KNIME examples on their servers that they. Now the final option we have is using custom URLs. So you can specify things like web pages if they point directly at data, or FTP or SSH. The critical thing for each one of them is that authentication cannot be required. If authentication is required, we're going to have to use a connector node instead. And that's going to be the next chapter. Let's take a look at, or in the next example. So instead of a standard file system, a connected file system is going to be one that begins with a connector node, and then the connector node is going to provide the authentication necessary to reach the data underneath it. So for example, you might be going after Amazon S3 buckets, or Google Cloud Storage, or a Google Drive connector, SharePoint site, Azure, anything like that. I'm going to go ahead and work with a Google example and put together a little working flow for us right now. Okay, for my Google example, I'm going to start in the node repository, and I'm going to start by just finding nodes with Google, and I'm going to need two things to make this actually begin to work. I'm going to want to use the Google Drive connector. I want to connect to my Google Drive. And you'll notice once I drop this up here that there's a node coming in and a node coming out. The incoming node port, is going to be for the authentication. So there's two Google authentication mechanisms. I can use an API key, or I can actually provide credentials. In this case, I'm going to keep my life simple here and just demonstrate the authentication method. So I'm going to configure here, and I'm going to have three options. I can control this through memory, which means my credentials will be stored in memory, or I can store my credentials after I've logged in into a custom directory, or I can store them as part of the node instance. And I can control the scope. What do I want this connection that I just made to be able to get at? Can I get at the drive, read or write? Maybe I just want read privileges on the drive, or Google Sheets, BigQuery. So I'm just going to keep it in memory for right now and keep everything simple. So I'm going to go ahead and sign in with Google, and I've already provided my Google credentials beforehand, so by doing that, it shows me as authenticated. So I can execute that node. Now my Google Drive connector, if I just browse from the Google Drive connector to say what's the working directory I want to be in, I just start at the root directory of my drive. Well, I don't want to actually do that. I'm going to instead say I want training presentations. That's the working folder that I want to start in. And I'll execute that. Now I'd like to list the files in that directory as the next thing I want to do. So I'm going back into the node repository, and I'll do list files in a folder. And now normally if you just work on a local drive like this, you see it's a local file system, and you'd enter the file directory that you want to do this from. But whenever you see a node in KNIME that has these three little dots right next to it, it allows you to modify the ports. By clicking those three little dots here, I'm going to add a file system connection port to it. So it's going to allow me to connect now the Google Drive port to this list directory. Now I'll come back in here and say I just want to list all the files, and I'll browse from here. Remember I started, well, I'm going to go into my training presentations and statistics and data mining class, and data files for modeling. Okay. That's going to be the working directory that I want to do. And I'll go ahead and click OK, and I'll execute this node. And now I'll right click, and you can see now I've got two files in that directory. I've got a sales win-loss CSV and a groceries CSV file. Now what's interesting is the data type you see that comes back here is a data type of path. This is a new data type that was introduced for KNIME file handling. If you actually looked at this value outside of Google, or outside of the viewer here like this, it would show you as a different structure that would contain what type of file, where it was located, like local, relative to, and so on. But for right now, it just shows you to make it human readable. So that's going to be the next thing we're going to talk about here, is we're going to go into using these types of connectors. But from here, by the way, I could simply turn around and I could download a file, I could read one of those files, so I can take my CSV reader and I'm going to, just for fun, I'm going to add table row to variable. This will take the first row that came back here and turn it into a variable. So you'll see here, now the variable, now you see how path shows differently. It's a connected file type from Google Drive, and this is the directory where it's located in. So I'm going to use that path now to do a CSV reader and tell it I want to use a flow variable, and the variable I want to use is the path. And the file system connection port is missing. What it's missing, I'm sorry, is the authentication. I'm sorry, I've got to close this, and I'm going to add the file system connection port, which is what this is looking for, right there, because this is what's passing that information. This gave me the file name. This is what's going to give me the reader. So I'll come back again one more time and enter the path. Say good. Now I'm able to read it, and it's reading the sales win-loss data and putting it out here. This is a standard file I use for demonstrating techniques for data modeling of building predictive models. But there, with the execution of this workflow now, I've just now connected to Google, my Google Drive, found the file I was looking for, and actually read it. Now I've taken the liberty here of showing you one more example here. I've extended the example we just showed, but this time a little different. Now I've added a table row to variable loop start and a loop end. So what I'm doing here is, since there are two files coming through like we had before, I'm going to run each one of them. So the first iteration of this loop, the output that I can see from it here is the first connected drive that it's going to read, and it'll execute the CSV reader. Now this will allow me to loop through all of the files in a directory and actually read them all together into one big large file. Only problem I've run into this historically is two things. First, the files must be the same. At least they must have the same columns. If I turn around and execute this and do the first execution of the step, it's read the first file. If I go ahead and step loop the execution a second time, okay, this time it's going to fail, and you see at the bottom the error message is that the input table structure is different from the first iteration, because the first one was a win-loss table and this one is something completely different. So the files do have to be the same. The other issue I have found, I found it very helpful with one example I did where I wanted to read all of the spreadsheets in a directory that were all Excel format. But a few of them were password protected and I couldn't read them. And I had no way of knowing which was which. There was about 2,000 files. So what I did is I built a try-catch loop in between to say, I'll try and read the Excel file, but if for some reason it fails, usually in the case of a password error, I just go ahead and pass on a null data set for that one and say I can't process it because I don't know what the password is anymore. But otherwise, this looping method is a good way for you to actually read all of the contents of a directory together. Now the last thing I want to show you is how to create a path data cell, because there are times where you might read the input file name for my user, for example, or it might come from another file inside your system, and you have to convert that into a path data cell. You need that data type. And so I'm going to show you how to do that using a KNIME node. All right, inside the node repository again, I'm going to do a search for create file folder variables. This is the node I want to drag up. And this can read, other variables can be fed into it. So again, you can configure this so that a file name could be read from somewhere else. But I'm going to go ahead and open this up now. And you'll recognize the base location, which is going to be where the base location shown right here. If I'm going to make this a local file system and the base location is my C drive temp directory. Okay? And so that's the base. And I'm going to call this, by the way, the variable name I'm going to create for this one, I'm going to call file1. And the value I want will be file1, and the extension will be CSV. You can type file1.csv here as a value and leave extension blank. It's not necessary to do this, but I'm going to add another one, and I'll call this one file2, and file2 also of a CSV data type. Now you'll notice if I try to double click here on the base location, you can't edit that. The base location is being determined up here. So now I'm going to go ahead and execute this, and let's look at the results we get now. Okay, file1 and file2 now, instead of them being just strings, their data type now you'll see is a path value, and it's a local file in the C temp directory for file1 and file2. So there's all kinds of different things that you can do with this node to help automate and make your workflows data-driven.
That completes this chapter of the class. Feel free to move on to the next chapter.